We're looking at determining if a function has an inverse, and if it does have an inverse, we are going to find it. Alright. I've got a step-by-step method on being able to find an inverse. If you follow my step-by-step method, no issues at all finding an inverse. You don't follow my method, you're on your own. It may be tough, but step-by-step method is flawless. So, determining if a function has an inverse, and if it does, find it. What's your prior experience with finding inverses? What do you guys know about finding inverses? Or Sky, what'd you say? No? What do you guys know about inverses? Anything? Throw it out there.
Basically, well, if you have a point to find the inverse of it, when you add an opposite sign and basically flip it, like so.
Alright, so you said we've got a point, do what with it?
Like you would add the opposite sign to it and then like flip it, I guess you could say over. Yeah, it's reciprocal. That's what for.
Alright. Not it, but that's a good try. You're somewhat on the right
Did you
track.
switch it from the x to the y and change the sign?
There you go. That's how a function and its inverses are related. The x and y's are switched. So what does that mean? What else is switched if the x and y's are switched? What's another word for, there you go. The domain and range are switched. So the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. Okay? Now here's what we need to know about. Well, first of all, it says a function has an inverse. So first of all, I know since it's a function, what has to happen? What do we know about functions?
There has to be like one.
Alright, so anytime I put an x value in, I have to get one thing out. So that means that the graph of it passes the vertical line test. Now, here's the key about a function and an inverse. Okay, in order for a function to have an inverse, the inverse must also be a function. Okay, the inverse must also be a function. So what does that mean to me? Alright, you're on the right track, and that's the first example I'm going to show you. Okay? She says, what if we started out with a parabola? Is a parabola a function? Yes. Okay? Now, I'm going to show you the inverse of this parabola, and then talk to me about the inverse of this. Okay? Now you can see the inverse of the parabola, which is now a sideways parabola. And the reason why this red line is drawn on there is that a function and its inverse are mirror images of each other over that y equals x line. Okay? So what's the issue when I take a parabola and then I turn it into its inverse? The inverse of it is not a function. Okay? So the first thing we want to do is figure out a way to look at a graph to tell whether or not it has an inverse. So how can I look at the graph of a function and tell whether or not it has an inverse? Pick it up right here. Alright, I want to be able to tell before I flip it. There's a way to tell before you flip it whether or not it has an inverse. Kathleen?
Well, with this parabola, the -1 is going to have the same as the other -1. It's going to have like the same y value, but they're different x values. So when you flip it, your y values are going to be the same.
Alright, you're on the right track. Okay, let's clean that up a little bit though. She's saying, right now, I think this is what she's saying. Right now, that, or my two ordered pairs here are -2, 0, and 2 zeros. Everybody agree with that? But what do those ordered pairs turn into whenever you find the inverse? 0, 2, and 0, negative 2. What's the problem with that? 0 has two y values, which means it's not a function. Okay? But let's go further than that. How can I graphically look at this? Right, but what can I use to graphically see that? What? Not the vertical line test, you're on the right track. The horizontal line test. Okay? The horizontal line test tells me whether or not a function is going to have an inverse. Because if I fail the horizontal line test, its inverse is going to fail the vertical line test. Okay, so that's how you tell whether or not a function has an inverse, is that it has to pass the horizontal line test. Yes? Breed, you have a question? No? Are you with me? Good. You had a concerned face. I was just double checking. Alright, so to tell whether or not a function has its inverse, we look at its graph and it must pass the horizontal line test. If it doesn't pass the horizontal line test, then its inverse is not going to be a function. If it does pass the horizontal line test, its inverse will be a function. Okay? So that's the first thing we want to think about today. So let's look at something. Let's look at something that will pass. Okay? So as we said, this one not going to have an inverse. What about this one?
No. Right there.
Yes, it does have an inverse. It passes the horizontal line test. Okay. You guys are getting hung up here in the middle. Remember, I said if it's going to be constant, it will be obvious that it's constant. It's not obvious that it's constant. So there's my. If I flip it, that's what I get. So does my inverse pass the vertical?
Yep.
Yes, my inverse is going to pass the vertical because the original passed the horizontal. Okay, so that's how I tell whether or not a function has an inverse or not. It must pass the horizontal line test. So now let's go through the process of finding the inverse. So given a function, we want to find the inverse. Okay, but before we find an inverse, what do we want to make sure of first? That it has one. So we need to figure out if it has one. And how do we do that? We can graph it. But do I even need to graph this one? What do we know it looks like? It looks like a line. What do you know about that line? Goes through the y-axis at 5. Except I think I graphed -5, so that's an issue. But anyways, it would just be the same graph up. Okay? So as you can tell, it passes the horizontal line test, so it does have an inverse. Does anybody remember the steps of finding an inverse? Because I'm pretty sure you guys did it in algebra 2. What do you got? That's probably if you want to do it graphically. I want to find the function. Okay? Anybody remember how to find the inverse of a function? What do you got? Alright, so here's the first thing I want to do. I want to take this function notation out and I'm going to put y in its spot. That's step 1. Okay, take the f of x, g of x, h of x, whatever it is, take that out, put y in its place. And then next step, we want to switch the x and the y. So I put an x there, I put a y there. Why does it make sense that we want to switch the x and the y?
It's the inverse.
Because that's how a function and its inverse are related. The x and y are switched, so that's why we're switching. So that's step 2. Anybody know what step 3 is? Solve for y is step 3. So what do you want to do to solve for y?
Well, don't we want to isolate them?
I want to get. How do I get y by itself? Subtract 5. So x minus 5 equals 2y, and then what? Divide by 2. X minus 5 over 2 equals y. And then the final step is to put it back into function notation. So I'm going to do x minus 5 over 2. Since I started with f of x, I'm going to write that down, but I need a way to identify that it's the inverse. Does anybody know how to identify it as an inverse? You put in a -1 up there. That tells you that you're dealing with the inverse of that. Okay, so what was step one? Replace the f of x, g of x, h of x, whatever it is with y. That's step one. Step two, switch x and y. Step three, solve for y. Step four, put it back in function notation. Okay? So, again, that's what it would be. Obviously, this is a little bit different than what I had since I didn't write the problem down right. But you would get a graph that is split over the y equals x line. Okay? Let's try the next one. Alright, f of x equals the square root of x minus 4. F of x equals the square root of x minus 4. Alright, but before I do that, what do I need to make sure of? That it has an inverse. Is this going to have an inverse? You guys know what it looks like? You should. What does it look like? Half a parabola. Half a parabola going to pass the horizontal line test? Yes. So here's what it looks like. Half of a parabola, it's going to pass the horizontal line test. So we're good to go. That means it does have an inverse. So you were saying step one was put y in. Good. So step one is put y in. Gage, what's step two? Switch what?
X and Y.
Switch the x and the y. Make sure we're paying attention. Okay, so I switch the x and the y. Matthew, what's the next goal?
You want to get that y over by itself.
I want to get y by itself, so what do you recommend we do to get started?
Square both.
Square both sides. And then all I have to do is
Side by 4.
add 4 over.
Yeah, but I did my calculator. It's different.
And then we change this to function notation. So there's my inverse, but we have a problem. It's a parabola, right? X squared plus 4 is a parabola, which means it shouldn't have an inverse. Now, let's go back to the graph of the square root of x minus 4. And it is, what did we say it is? Half a parabola. So what should the inverse end up being? It should also be half a parabola. Okay? But let's go back and talk about how is a function related to its inverse. What did we say? The x and y values are switched, but what else is switched? Domain and range are switched, right? So the range of the original function turns into the domain of my new function. Okay? So what I need to do is I need to find the range of the original, and that's going to turn into the domain of my new one, which will restrict it to where it's half of a parabola. So, what is the range of this original? 0 to infinity is the range, so that means my domain is 0 to infinity. So I want to restrict this, and let's just say x is greater than or equal to 0. Okay? So that means I have x squared plus 4, but I'm going to only look at x values greater than or equal to 0, and that should give me half a parabola. So let's look at that. Again, I have the x squared plus 4. I've told it I just wanted x greater than or equal to 0, and notice what do I have? I have half a parabola, which does have an inverse because it passes the horizontal line test. Okay? So, if you start with a square root or any type of even root, know that you've got to put restrictions on what you end up with. Okay? And what do we do to get those restrictions? How do we get the restriction x greater than or equal to 0?
Finding the range
Of
the original.
find the range of the original function. That tells you the restriction. Okay? So if I'm doing any type of even root, find the range of the original, that turns into the restrictions of the inverse. Okay? Next one. Alright, I have g of x equals 2x cubed minus 5. G of x equals 2x cubed minus 5. Colleen, what do I want to do to get started? See if it has an inverse by looking at the graph and determining if it passes the, not the vertical, the horizontal line test. Okay? What should this look like? It should look like the disco function. So here's a graph of it. Does it pass the horizontal line test? Yes. So we're good to go. So now we're ready to start the process. So Kendrick, what's step one?
Substitute g of x for y.
Replace g of x with y. Alright, Kurt, what's next?
Switch the y back.
Switch the x and the y. Very good. Lauren, what's next?
Did you add 5?
Add 5. So what are you trying to do?
Isolate the y.
Get y by itself, so you add 5. Then what?
Cube it.
Not yet. I gotta do one more thing for it.
Divide by 2.
Divide by 2. And then I can cube root it to get y by itself. And put it back in function notation. So I get my inverse to be the cube root of x plus 5 over 2. So let's graph that to see what it looks like. So there's the original, and there's the inverse. Okay, cube root of x plus 5 over 2. Alright, let's do one more, finding the inverse. Alright, h of x equals x plus 4 over x. H of x equals x plus 4 over x. So Carson, what do I do to get started?
You would figure out if it was a function. Or,
I'm-
I mean, if it would pass the horizontal test.
Alright, so what do you think this thing looks like?
I'm not sure.
Not sure. Does anybody have an idea of what it looks like? Yeah, it looks like it might be the asymptote graph, right? So let's see what it looks like. We'll go ahead and graph it. Sure enough, it's the asymptote graph. Alright, so it does pass the horizontal line test. It is the asymptote graph, so we go back. We're ready to get going. So Kaylee, what do I do to get started?
You plug in y for h of x.
Alright. Okay, Lindsay, what's next?
You switch your x.
Switches the x and the y's. Notice I have two x's, so I'm going to end up with two y's. So we get x equals y plus 4 over y. This one's a little bit more complicated to solve. Bree, any thoughts on what to do next?
Solve for y.
I do solve for y, you are correct. How do I get going on that?
That's a good question.
It is. Multiply by y, very good. So I get xy equals y plus 4. Reagan, any thoughts on what to do next?
Just subtract the 4.
Don't want to do that. Good thought though. Kendrick,
Divide by x on both sides.
don't want to do that either.
Subtract the y.
Subtract the y is what I want to do. The reason why I don't want to divide by x is because then the x just goes to that other y.
Okay.
Okay? So, but I do, as AJ said, want to subtract the y. Now the next step is what we usually have trouble seeing. But usually somebody can see what we need to do. Anybody know what needs to happen next? Kathleen?
Factor y out.
There we go. That's the trick to this problem, is getting here and then factoring the y out. Now I just have one y and we're in good shape. Okay, so Hunter, what needs to happen next? Multiply it? Divide by it? And then change the notation. We're dealing with h, so h to the negative 1 of x equals 4 over x minus 1. Okay, there's my inverse. So we look at the graphs. there's the graph. Those graphs aren't very much different, but you can tell it was split over the line y equals x. So when I'm finding an inverse, first thing I need to do is make sure it passes the horizontal line test. Next thing, put y into the problem. Next thing, switch x and y, then solve for y, and then put it back in function notation. Now, if I started with the square root or an even root, what am I going to have to do? Make sure I put restrictions and find those restrictions. I look at the range of the original. All right. Now, these last two problems, they're going to give you a graph, and from the graph, they want you to draw the inverse. Okay? These last two are pretty easy. So, here's my function. Does it have an inverse? Yes, passes the horizontal line test. So we want to find, or be able to draw the inverse. Any thoughts on what we need to do to be able to draw the inverse? Right, there we go. As Natasha said, we want to pick a couple points out, and then what do we want to do with those points? Switch the x and the y. So what are some points we see up here? I'm going to say 0, I'm going to say 0, -7. So that means the point that goes with it is -7, 0. So we got a point right there. All right, what's another point you see? 2, 2. And what point goes with 2, 2? Obviously 2, 2 does. Just switch the 2's, you end up in the same spot. How many points do I need to be able to draw a line? 2. I've got 2 points. We're ready to go. So I do my best to draw a straight line. And there's the graph of that function's inverse. There's the graph of e to the -1 of x. Okay, let's do one that's a little bit more involved. So, what is the parent graph of this? Or the parent function of this? X cubed is the parent function, good. So let's pick out some points that we can switch. What are some points you see? I'm hearing a bunch. 0 what? 0, -6. Yeah, I'll go with that. So what's the -6, 0? So we'll put that right there. What else?
2, 0.
And it looks more like, I'm going to call it 3, 0. I'm going to call it right there. So that means the switch of that is
0, 3.
0, 3. What else? 6, 6. So 6, 6. So the reverse of that is also 6, 6. All right, let's find a point. Let's find a point on the left of 3 and a point on the right of 3.
Five, 2.
How about this point right here? What's that point?
1, 2. 1, -2.
1, -2. So the reverse of that is -2, 1. And let's do this one right there. What's that one?
5, 2.
5, 2. So the reverse of that is
2, 5.
2, 5. So we'll put it right there. That should give us enough to be able to draw the inverse of this. So we'll curve this here. And we'll curve that there. And how's it look? Do we like it? Yes, we like it because it looks like it's flipped over the line y equals x. So that is determining if a function has an inverse and find it if it does. How do I tell if it has an inverse? Passes the horizontal line test. Okay, and then we have that 4-step process to be able to find the inverse. Any questions? Okay. All right, 38 to 42 are the ones you need to draw. I have a sheet of paper with the graphs on there, so it'll be easy for you guys to draw those, and I'll bring those around in just a second.